Hello class and welcome to lesson 2.5, creating equations from graphs and from information. So last class we were given transformation information, or we were given an equation, and then we needed to create a graph. Now we're going to work backwards and we're going to be given the transformation information and we have to come up with the equation. All right, so basically what we need to do is you can determine the equation of the sinusoidal curve when given a graph or a description of the transformations of the corresponding parent function. All we need to do is to be able to identify our A, K, D, and C information and then substitute it into the transformation formula. All right, let's get started. So example 1, the transformation of a function whose parent function is y equals sine x, so that's where we're basing it from, has to be reflected by the x-axis. Reflected by the x-axis means a has to be negative. It also says that it's been vertically stretched by a factor of 4, so that tells me a is negative 4. Moving on, it says it's also horizontally compressed by a factor of 1/3. Remember, the factor of 1/3 is 1 over the absolute value of k. So you flip that and k equals 3. Okay. Next, we notice that we have that it shifted 45 degrees to the right. That tells us D, our starting point, is 45. And lastly, it says that it's translated 5 units up. Okay, so 5 units up means C is 5. So all we need to do, ladies and gentlemen, is step 1, identify our A, K, D, and C like we did, and substitute into our transformation formula. So what we know is we know that our parent formula is the sine function in this case. We just need to sub in our values for A, K, D, and C. So let's do that. So y equals a, which is negative 4, sine of, what's my k value? 3, times x minus my d value, 45 degrees, and plus my c value, which is 5. Okay, that's the first part. Then it says second part to state the key features. So what do we know? If a equals negative 4, that tells us that the amplitude, which remember equals the absolute value of A, which equals absolute value of 4. So our amplitude equals 4. We know that our axis equation, here's my short form for equation, is y equals c. So what does that tell us? That y equals 5. We also know that our period equals 360 divided by the absolute value of k, equals 360 degrees divided by 3. So our period is 120 degrees. And if we wanted to know our starting point, what's our starting point? And that equals 45 degrees. Okay. The other things we might want to take a look at doing, if I can just move this down a little bit, another key feature would be your max and your min. Okay. So max equals our C value plus our amplitude. So in this case, that equals C is 5, so 5 plus 4, which is 9. Our minimum value equals C subtract the absolute value of A. So that's going to be 5 subtract 4, which is 1. So then if you wanted to discuss your range, you could now tell me that y belongs to set of real numbers such that it has to be between 1 and y has to be in between 1 and 9. Let me just fix that up. So that we have, sorry, I'm just going to backtrack here. So 1, y, and 9. All right. And if they ask you for your domain, don't forget domain is that X belongs to a set of real numbers. There's no restriction because a function is periodic and wave-like and it continues on in both directions. All right. Okay. Now it says let's explore how to create equations from a graph. So we're going to do the exact same thing, just be able to from a graph pick out what A, K, D, and C are, and once we get that, then we're going to sub it into the equation. All right, let's take a look here. So first of all, it says state A, K, D, C values, then create the equation. All right. So look here, first of all, amplitude. So the amplitude equals 1, therefore that tells me A equals 1. Looking at the period. Okay, how long's our period to complete one wave? Period equals 360 degrees. Therefore, K equals 1. Just want to remind you guys that remember the period equals 360 divided by the absolute value of K, but we can switch K and the period. So K equals 360 degrees divided by the period you see on your graph. So that's where we're getting K equals 1. Okay. Next, we're going to take a look at our axis. Okay, our axis occurs at Y equals 0. Therefore, that tells us C equals 0. And lastly, ladies and gentlemen, our starting value. So it starts at 0 degrees. Therefore, my D equals 0. So looking at this, ladies and gentlemen, what graph does it look like? If it starts at 0 and it goes up to its maximum, then to its minimum, then back to the axis, then we know, ladies and gentlemen, that it's a sine. So y equals sine x. So that's your parent function. I just wanted to show you that we could do it from a parent function. Now we're going to make life a little more difficult in our second example. So take a look at B. Okay. First thing I note, ladies and gentlemen, is B. I'm looking at my axis here. So I'm looking for my axis, so I kind of highlight this. What does that tell me? If axis is 3, that tells me that C equals 3. So far, so good? All right. Next, I'm going to take a look at the amplitude. So from that, ladies and gentlemen, how far up do I go? A equals 3. Okay, because the amplitude equals 3. Now we got to double check if it's going to be positive or negative, but looking where it starts up at its maximum, so it looks like it's going to be positive. Okay, what's my period, ladies and gentlemen? How long does it take to make one revolution? Okay, that's 360 degrees. That tells me K equals 1. And the last point is my starting position. First of all, what does this graph look like? It looks like cosine. Okay, you could also make a graph here of sine of the sine curve, except you're just going to have to translate it 90 degrees. Okay, so taking a look here, folks, we know it's cosine is the easiest one to graph. Looking at our starting point, it actually starts at the y-axis. So what does that tell us if we're looking at cosine? That actually tells us that D equals 0. So let's just recap here, guys. We know that A equals 3. We know that K equals 1. We know that D equals 0. And we know that C equals 3. It looks like cosine, so if we had our function and we're going to sub it in, we're going to have y equals A, which is 3, times the cosine of K, which is 1, x minus 0, which is D, so it's just going to be cos of x plus 3. All right, let's try another one. All right, so let's try C here, ladies and gentlemen. First of all, what does the graph look like? In this case, it looks like the sine x, right? Y equals sine x. All right, how do I know that? Because If I look at my axis, it starts at my axis. All right. So if the axis is at -3, what does that tell us? C equals -3. If I try to find my amplitude, A equals 1 because it goes a distance of 1. My K, let's take a look at K here, folks. K is the length of time it takes to get 1 revolution. So if I look from axis to 1 revolution, it looks like 180 degrees, guys. So if I know it's 180 degrees, K equals 360 divided by the period we have here. So we got K equaling 2. And looking for our starting value, D, it looks like it starts right at the y-axis. So we're going to say D equals 0. So again, it looks like the sine curve. Next day, we're going to be doing examples where we make one equation from the sine curve, one from the cosine curve. So it doesn't really matter which one you use. I always try to do the one that looks easiest. So it looks like here, the easiest one is to use the sine curve. So we're going to sub it in. Y equals A, which is 1, sine of K, which is 2. And again, it's x minus 0, so it's just 2x. And we're going to subtract 3. All right. Let's take a look here. All right. Now, this is what's going to be similar to your homework, so we're just going to try doing this in a different little bit of format. So taking a look, we're going to write each equation, and the hint is to think about the amplitude, the period, and the equation. Just remember, the amplitude's going to give you your A in most cases, as long as it's not reflected. Your period's going to give you your K value. Your equation is going to give you your C value. And don't forget to take a look at your start value, because your starting point gives you your D. All right? So let's take a look. The period. How do we figure out the period, ladies and gentlemen? What length of time do we have here? Looking at this, ladies and gentlemen, it looks like 120 degrees to get from there to there. So how do we figure that out? So we know if the period equals 120 degrees, we use that information in defining K. So K equals 360 degrees divided by 120 degrees. So what does that tell us? That K equals 3. Amplitude, let's take a look from its axes, which is x equals 1. How far are we amplituding up to the maximum or down to your minimum? Amplitude equals 1, therefore A equals 1. So I'll just circle these important pieces so we know when to substitute it. Equation of axis, ladies and gentlemen, that is y equals 1. What does that tell us? That C equals 1. So the only other part we have to take a look at is our starting point. So looking at our starting point, it looks like if we're going to use the sine curve here, so it looks like sine. Sorry, sine curve or sine function. Okay, and looking at that, ladies and gentlemen, D equals 0. So what is our equation here, folks? It's going to be y equals A, which is 1, sine of K, which is 3, x minus 0 plus 1. All right. So you're going to do some examples like that. Watch for D to change. And your homework today, guys, is to complete the next couple pages, which is example 4 to 8, just like this, and read the helpful hints page. So looking at this, folks, we've got example 4, 5, 6, 7, 8. Helpful hint is just a summary, ladies and gentlemen, of what we've gone through the last couple days, how to find some values that you may be having trouble finding. Okay, so it's just a little helpful hint on an example of doing this. So again, ladies and gentlemen, have a great day, and if you need some help, please come see me in class and use the handout and have some fun. All right, have a great day.